All right, today we are going to learn the third and final method for solving a system of linear equations, and that is called the elimination method. Now, sometimes this is also called linear combinations. So if you see the phrase linear combinations in ALEX or just in, things that you see online, that means the same thing as the elimination method. So we've got 5 steps when solving a linear system by elimination. The first step is to arrange our equations in columns with the variables on the left and the constants on the right. So in general, we have x's plus or minus your y's equals your constants is the general idea. Now, of course, if you have different variables other than x's and y's, same thing. It doesn't matter whether the x's or the y's are really first, as long as they're on the other side from those constants. Then, step 2, we are going to obtain opposite coefficients. Remember, opposite means that the signs are different. So the opposite of 7 is -7. The opposite of -2 is +2. So we're trying to get the coefficients on one of our variables, either the x's or the y's, to be opposites. The way that we do that is we multiply one or both of the equations by a constant that's going to give us those opposites. Now, sometimes we're lucky and we already have opposites. And depending on the system, sometimes it's easier to obtain opposites than others. Like I said, sometimes they're already opposites and we don't have to do anything. Sometimes we can just multiply one of the equations by something to get those opposites. Other times we're going to have to multiply both equations by something. So we'll do examples of each of those items. Example 3, once you've obtained opposites, we're going to add the equations together. So when we add the equations, we add them in columns. So we add down the columns. That's why in step 1 we line them up that way. What's going to happen when we add the columns, because we have opposites, is that that variable is going to be eliminated. Hence why we call this the elimination method. When one variable is eliminated, that means there's only going to be one left, so we can solve the equation that remains. So we'll either end up with, at the end of step 3, x equals a number or y equals a number. In step 4, we then go back kind of to substitution, and we substitute that answer into one of the original equations, and we solve for the other variable. Then, just like in substitution, we're going to write our answer as an ordered pair, and we're going to check our solutions. What we went over in 17.2 about the special cases is still true. Just because we're using elimination instead of substitution doesn't mean that the possibility for no solution or infinitely many solutions goes away. We could still have systems that have no solution or infinitely many. Okay, so let's go through these steps. Example 1, which all of it's example 1. First step, arrange equations in columns, variables on the left, constants on the right. So if I look at my 2 equations, both of them have x's, then y's, and on the other side they have the constant. So in this case, step 1 is already done. So already arranged in columns. Step 2, obtain opposite coefficients on one of the variables. So on my y's, I have 2 and I have 4. Those are definitely not opposites of one another. On my x's, though, I have -3 and +3. Those are already opposites. Step 2, done with the x's. The x's are already opposites. So I get to skip 2 of the 5 steps. They're already done. Step 3, I'm going to add the equations. And like I said, we're going to add down in the columns. 3x plus negative 3x is 0x, which means we've eliminated the x. You don't have to write 0x. Those drop out. So then I go to the next column. 2y plus 4y gives me 6y. And then my last column, make sure you put the equal sign first. 7 plus 5 gives me 12. So I added the equations to eliminate one variable. Now I'm going to solve the remaining equation. So to solve for y here, I just need to divide both sides by 6. That gives me y equals 2. So now step 4, substitute this answer from step 3, the y equals 2, into one of the original equations and solve. Again, just like with the last lesson, it doesn't matter which original equation you choose. I generally choose the one that either has smaller numbers or has fewer negatives. That's up to you. I'm going to choose the top one this time. So we have 3x plus 2 times, instead of y I put 2, equals 7. 2 times 2 gives me 4. So I have 3x plus 4 equals 7. Minus 4, minus 4. Those go away. 3x equals 7 minus 4 gives me 3. So divide both sides by 3 to get x alone. And I get x equals 3 divided by 3, which is 1. So I have x equals 1, y equals 2. So that means my ordered pair solution is 1, 2, and I'm going to check it. So 3 times 1 plus 2 times 2, I'm seeing if that equals 7. 3 plus 4, yes, does equal 7. So it checks in that top equation. Now I'm going to check it in the bottom equation. Negative 3 times 1 plus 4 times 2, and I'm checking to see if that equals 5. So I get negative 3 plus 8, which yes is 5. So 1, 2 is my ordered pair solution. Let me just hammer home again that we solved this system algebraically. That doesn't change the meaning of the answer. The reason it's still an ordered pair is because if I were to graph these two standard form equations, they should intersect at the point 1, 2. So the solution is still representing an intersection point. Okay, let's look now at part B. We'll switch colors again so that way we're not running into each other. So step 1. We line up in columns. So I've got x's, y's, and then after the equal sign, I've got constants. So step 1 is already done. Step 2, on my x's, I have coefficients of 1 and negative 2. Those are not opposites. I have negative 1 and positive 2, also not opposites. So step 2 is not done here. So what I want to look for is I want to look to see, okay, which equation, if I multiplied it by something, could I easily get opposites? So I look at my x's here and I say, okay, this coefficient is negative 2. The opposite of negative 2 is positive 2. Right now, this says 1x and this says negative 1y. If I multiply 1 by 2, then that means I would have opposites on my x's. So step 2, I'm going to multiply top by 2. So I put parentheses around it. I put the 2 in front. Now, when I do this, I highly suggest rewriting the entire equation underneath. If you were multiplying the bottom equation, I would suggest rewriting both of them. So when I do 2 times 1x, that gives me 2x. 2 times negative 1y is negative 2y. And don't forget the constant. It has to be the entire equation. So 2 times 2 gives me 4. So I have now Multiplied the top equation by 2. That gave me this guy. I don't need to multiply the bottom equation by anything because by multiplying those, I got opposites on my x's. So step 2 is now done. I multiplied the top by 2. Now I have opposite coefficients on my x's. So step 3, add the equations in those columns. So 2x plus negative 2x, those are opposites. Those cancel out. Go to the y's. Negative 2y plus 2y, those also cancel. So I've got nothing left, which means I have 0 left. On the right side, I have 4 plus 2, which is 6. So in this case, both of my variables dropped out. When both my variables drop out, that's when I know it's a special case. This equation that I have left is, so both variables dropped out. Write this down, please. And the statement is false. So that means when it's false, that my answer is no solution. If I had gotten a true statement, like 0 equals 0 or 6 equals 6, then we would write infinitely many solutions. All right, now we're going to look at part C. So on this one, step 1, line them up in columns. These are not lined up in columns. So this 3x is in the wrong place. I need to move it over to the left side. So what I want you to do is answer the question for me. How do I move this 3x over to the left side? All right, so hopefully you said that to move this 3x term over to the left side, we would need to subtract it. So when we do that, these cancel out. Again, I suggest rewriting the system, even if you have to do it several times, so that everything is lined up nicely. So on the left side, I'm just going to recopy the top system, 2x plus 5y equals negative 11. And then now I have negative 3x. This 5y was positive. So plus 5y equals, be careful over here on the right side. The x is canceled, but this is a negative 21 that remains. All right, so step 1 is done. I've got everything lined up nicely in columns. So now my next step is to obtain opposites on one set of variables. When I look at my x's, I have 2 and negative 3. Obviously, those are not opposites. And there's no integer that I can multiply 2 by to get negative 3. So if I choose the x's, I would have to multiply both equations by something. So I'm going to take a look at the y's first before I choose to do that. So when I look at the y's, I have 5 and 5. So those are the same number, which means that I can get opposites by simply multiplying one of these by negative 1. So it doesn't matter which one you choose. Since this one has more negatives, I'm going to choose to multiply this second equation by negative 1. So multiply negative 1 to get opposites. Now again, that's just on the bottom equation. So I'm going to copy the top equation exactly as is. So 2x plus 5y equals negative 11. So now when I multiply the second equation by negative 1, negative 3x times negative 1 is positive 3x. Positive 5y times negative 1 is negative 5y. And then negative 21 times negative 1 is positive 21. So step 2 is now done. I've obtained opposites on my y coefficients. So I go to step 3 where I'm going to add them. So remember that we add down in the columns. So I want you to do that on your own and tell me the equation that should remain once you add all 3 columns. So add the x's, add the y's, write your equal sign, add the constants, and tell me the equation that should remain. All right, let's check and correct. So 2x plus 3x should give you 5x there. 5y plus negative 5y gives me 0, so those are eliminated. Negative 11 plus 21 gives me 10. So 5x minus 10, or 5x equals 10 should be your answer to that question. Now, to finish out step 3, I need to solve the equation that remains by dividing both sides by 5. And so x equals 2, because 10 divided by 5 is 2. So we did step 3. Now step 4, substitute that answer that we got, x equals 2, into one of the original equations. Again, doesn't matter which one, but one of the original equations. So I'm just going to use the bottom one here since the y is closer to being alone. So I do 5y equals, I'm substituting 2 for x, so 3 times 2 minus 21. So 3 times 2 is 6, and 6 minus 21 is negative 15. So now I am going to divide both sides by the 5 in order to solve for my y. So divide by 5 over here, divide by 5 over here, and so I end up with y equals negative 3. So last step, write it as an ordered pair. So take these two solutions, write them x, comma, y, and then check it in both originals. So 2 times 2 plus 5 times negative 3. We're checking to see if that is negative 11. So 4 minus 15. 4 minus 15 is negative 11, so that works. Now check in the other. 5 times negative 3. We're checking to see if that equals 3 times 2 minus 21. So negative 15 equals 6 minus 21. Yep, it sure does. So I know that my answer is correct. All right, moving on to the last one. Last example. So step 1, make sure that everything is lined up in columns. So x's, y's, equal signs, and then my constant. So step 1 is done. Again. Step 2, I need opposites on my coefficients. So I look at my x's, 2 and 3. Obviously not opposites, and when I ask myself if there's anything I can multiply 2 by to get negative 3, that would be no, there's not an integer. So then I look at my y's. So they've already got opposite signs, but I look and there's nothing I can multiply 4 by to get 5, which is the opposite here. So that means that in this case, I'm going to have to multiply both equations by a constant. So in general, there's always choices here. I am going to, because the y's already have opposite signs, I'm going to choose them. because if I choose the x's, that means I'm going to have to multiply by a negative. And just, it's not that you can't do that. You most certainly could. But I just find that students make more mistakes when they're multiplying by a negative number than when they're multiplying by a positive. So if I have a choice, I'm going to choose to multiply by the positive. So I am going to, if I look at 5, the multiples of 5, 5, 10, 15, 20. Well, 4, if I list its multiples, 4, 8, 12, 16, 20. 20 is a multiple of both of them. So I'm going to get these coefficients to say 20 and negative 20. So I'm going to multiply the top by 5, because that's going to give me 20y, and the bottom by 4, because if I multiply negative 5 by 4, I get negative 20, and that'll give me my opposites. So top by 5, bottom by 4. Again, rewrite the system. Remember here, I'm distributing the 5 to all the terms. So 5 times 3x gives me 15x. 5 times 4y gives me 20y. 5 times 6 gives me 30. Then I go and do the same for the bottom. 4 times 2x gives me 8x. 4 times negative 5y gives me negative 20y. And 4 times negative 19, if you need a calculator, use it. If it were negative 20, 4 times negative 20 would be negative 80. So I know that it should be 4 off of that. So negative 76 would be what I would get there. All right, now I have opposites. Again, you always have a choice here. I did this so I wouldn't have to multiply by a negative. You could multiply the top by negative 2 and bottom by 3 if you wanted, because that would give you negative 6x and positive 6x. So again, you have a choice. As long as you get opposite coefficients, it doesn't really matter what you choose to multiply by. So now I'm going to add the columns. So 15x plus 8x is 23x. 20y plus negative 20y is 0. Those are eliminated. And then I've got 30 plus negative 76, which gives me negative 46. Now I'm going to solve for x by dividing both sides by 23, which gives me x equals negative 2. So that's the end of step 3. Step 4, I'm now going to take this solution and substitute it into one of the original equations. So this is for you to do now. Take negative 2, plug it in for x in one of your original equations, and then tell me what you get for y. All right, so checking your work here. I'm going to choose to substitute into the top because the numbers negative 19 is, bigger than 6. So I'm just going to use the top equation, but if you used the bottom, that's totally fine. You should have gotten the same answer if you did it correctly. So 3 times negative 2 plus 4y equals 6 is my first step. Do 3 times negative 2 next, so negative 6 plus 4y equals 6. Add 6, add 6. 4y equals 12. Then divide by 4, divide by 4. I get y equals 3. So my ordered pair solution here should be negative 2, positive 3. And then I'm going to check it. So 3 times x, which is negative 2, plus 4 times y, which is 3. Checking to see if that equals 6. So negative 6 plus 12, yep, Sure is 6. Now try the second equation. 2 times -2 minus 5 times 3. I'm checking to see if that is -19. So this gives me -4 minus 15, which, yes, is -19. So I've checked, and I am sure that this is the correct solution. Again, remember that that means that if I were to graph these two standard form equations, that they would intersect in one place at the point -2, 3. So keep going back to that 17:1. If you get an ordered pair, that means the lines intersect in one place. If you get no solution, that means that the lines are parallel. If you get infinitely many solutions, that means that the equations represent the same line. All right. Again, I can't stress enough how much this has to be practiced. The only way you get better at this is by continuing to practice it. So please do all of the practice problems and reach out for help if you have questions.